In these next two sections, we'll be solving linear inequalities. So first of all, what is a linear inequality? These are inequalities listed in the center of the page here. X less than 2, let's look at the graph. Notice the open circle because we don't want to include 2, but we want all the real numbers to the left of 2, so that's the first graph. X greater than negative 2, again, open circle at negative 2, we're not including that value, but we want all the real values to the right. X less than or equal to 1, now we want the 1 included, so notice that that's a filled in point there with the real numbers to the left. And again, the same thing for x greater than or equal to 0, that filled in point. So make sure you can represent inequalities on a graph. So before we start solving inequalities, let's look at an inequality that's true. 2 is less than 5. As we perform different transformations, we're going to take a look at that truth value and make sure that it holds. So if we add 3 to both sides, this will be the first one, then on the left we get 5, and on the right we get 8. And notice that's still true. 5 is less than 8. If we subtract 2 on both sides, or add a negative 2, then we get 3 is less than 6. Notice that's still true. If we multiply by 4 on both sides, we get 12 is less than 24, which again is still true. If we divide both sides by 2, we get 6 is less than 12, which again, 6 is less than 12, so that's still true. But look what happens if we multiply both sides by a negative 3. We get negative 18 compared to negative 36. Well, it would no longer be true if I put a less than there. So when we multiply both sides of an inequality by a negative, we're forced to switch the direction of the inequality. We multiplied by negative 3 on both sides, so we had to switch from less than to greater than. Now notice, same thing if we divide by a negative 1. If I divide by a negative 1, I get 18 on the left and 36 on the right. Well, it would no longer be true to bring down that greater than. So when I divide by a negative, I have to switch the direction of the inequality. So if you notice the left-hand side over here where I have checks, when we added 3, subtracted 2, multiplied by a positive 4, divided by a positive 2, that inequality, I just brought it down like we used to bring down the equal to. It was only when we multiplied by a negative number or divided by a negative number that we had to switch the direction of the inequality. So if you start at the bottom of the page here, adding or subtracting a number from each side, you do not change the inequality. You would continue to bring down a less than if that's what it were, or greater than or equal to. If you go up to the top now, multiplying by a positive 2 keeps that inequality the same. Dividing by 3 keeps it the same. But multiplying by a negative 1, so we took that negative x less than 4, when we multiply by a negative 1, we know we have to reverse the inequality symbol. So that's why it becomes x is greater than negative 4, which will affect a lot of your problem solving. Same thing down here. To solve this last one, we'd have to divide by a negative 2. But dividing by a negative 2 means we have to reverse that direction of the inequality. So when we get x on the left, we'll now rewrite it as greater than or equal to negative 3. If you're confused about these rules, make sure you go back and replay the last two. So before we start solving inequalities, let's just take a look at a word problem here just to see how the inequality fits in. You finish a 3-mile walking race in 27.5 minutes. Write an inequality that describes the average speed of a walker who finished after you did. So we know average speed rate is distance over time, total distance over total time, which in this case would be 3 miles divided by 27.5 minutes. And since we don't want to leave fractions or decimals within fractions, If we just double the top and double the bottom, that would be an easy way to get rid of the 0.5. So we get 6 miles over, and if we double 27.5, we're going to get 55 minutes. So there's the rate of that actual walker, and we want an inequality that describes a walker who finished after you did. So we'll say the walker's rate would be slower, so we want less than, smaller than 6 miles per 55 minutes. Again, you could punch that out and get what that is per minute, but that's what the inequality would look like. So now as we begin to solve inequalities, and there's 2 on this page, we'll do these 2 together and then I'll give you some to do. So if you take the first one on the left here, basically to solve for x, of course I want to subtract the 5. So I'm going to subtract 5 from both sides, and again, subtracting a number does not change the direction of the inequality. However, right now, to solve for x, I need to divide by -3. As soon as I say divide by the negative, I'm thinking, whoops, I got to switch that direction. So I circled it just to remind myself. So now when I solve, I get x is less than -11/3, and that would be the solution. So take the one on the right. So again, we're solving for x. The x is over on the right this time. There's one thing added to it and one thing multiplied. So we're going to subtract 24 from both sides. So -16 is less than -2/3 x. Again, when we subtract, we don't have to switch the direction of the inequality. Now we're going to multiply both sides by -3/2, the reciprocal. We're going to multiply a -3/2 on the left and a -3/2 on the right. But as soon as I'm thinking I'm multiplying by a negative, I've got to think switch the direction of the inequality. So I'm going to reduce the 2 into the -16 to get -8. So on the left I get +24. I'm going to switch the direction of the inequality. After I did that arithmetic, it helped me because I had the circle there, so I couldn't forget. I remember, oh yeah, I got to switch that. And then on the right, of course, we just get +1x. So our answer would be x is less than 24. So copy this problem in your notebook, hit pause on the video, and do the problem out. So this one I have already worked out, so if you didn't get x is less than -2/7, just check the steps. Did you distribute the negative? -3x minus 8. Then I combine like terms to get -2 on the left, 6 and -8. Then I added 10x to both sides. Now right there, I have a choice. Remember, when we have a negative coefficient of x and we divide it out, we're going to have to switch the direction. But right here, I have a choice of which side I take that x to. I'm going to choose the smaller one, the -10x. If I add 10x to both sides, I end up with a +7x. So I'm not going to have to remember that other step of switching the direction. So when you have a choice, you might as well do it easier. I think I've gotten you hopefully used to that. Move the smaller one and you won't have a negative coefficient. We make less mistakes with positive coefficients. So it's a good way to do it anyway, even if it's an equal to. Then, of course, I added 2 to get -2 and divided by 7. So x is less than -2/7. So now copy this problem in your notebook, hit pause, and do it out. So when you resume play, you should see the answer is x is less than -8/3. If you didn't get that, look at this carefully, right? I distributed, combined like terms, 8 minus 14. Then I added 6 to both sides. And then when I went to divide by the -6, again, notice in blue I circled the inequality thinking I got to remember to change that. I have to switch the direction of the inequality. So just a review problem here, just to talk about those linear format of a word problem again. In 1990, Nashville, Tennessee had a population of 985,000. From 1990 through 96, the population increased at an average rate of about 22,000 per year. There's your constant rate of change. So there's your slope times the number of years. And then here's that initial value that's added on, and that would be a linear algebraic model for that population. Notice the graph. The y-intercept would be that initial value, 985,000, and then that constant rate of change over those years after 1990. So here's a word problem. It says you see an advertisement for instructions on how to tie flies for fishing. The cost of the material, so this is cost, for each fly is 15 cents. You plan to sell each fly for 58 cents, and you want to make a profit of at least $200. How many flies will you need to tie and sell? So basically we want to figure out what our profit formula would be. Now notice first of all over here in the announcement they say you have to send $13.95 plus $1.05 for shipping and handling. So there you have an added expense, right, of $15. So hit pause a moment and see if you can write this profit statement. So hopefully you wrote that you're going to bring in 0.58 times the number of flies. That's the income. But you have to subtract the costs, and the costs are 15 cents for every one of the flies, and that $15 that you had to send. And all of that, then, that difference is your profit, and you want that to be greater than or equal to 200. And solving that inequality, you get down to then you have to sell 500 or more flies. So they distributed, combined like terms, added 15, and divided by 0.43. On the graph, notice, so the one line is the sales there, that one, right, the 58 cents times every fly, so that's the income. And then what you're paying is down here, that's what you end up spending. So notice, as soon as you get past there, you should be making a profit. But you want to make at least $200, so that's where the profit is, 200 or more. So to finish off here the last couple problems, because you'll be doing a lot of these tomorrow, again you're going to subtract 3, which does not change the inequality. You get less than 4. Then you're going to multiply both sides by -2. As soon as I decide I'm multiplying by a negative, I'm going to circle that, and that's going to give me x is greater than -8. So why don't you pause this one and try one more. Now just review your work. Did you distribute the 2x minus 16? Add x to both sides because it'll look a little simpler. You won't have to switch the direction of the inequality. Added 16, 20 is less than 3x, and divided both sides by 3. So we got x is greater than 20 over 3. Again, I'm reading from right to left. This problem says write an inequality for the values of x if the area is less than 30 square feet. So I wrote here the formula. This is actually a trapezoid. When you have two sides that are parallel, that's what these arrows mean, that those two sides are parallel. The formula is 1/2 the height, which in this case is x, times the sum of the bases. Those are usually written as little subscripts like that, but I was typing it. So, all right, so the area here is 1/2 x times 2 plus 4, which is 6, which makes it 3x. And then the problem tells us that the area is less than 30 square feet, so we're going to write 3x is less than 30 square feet. Divide both sides by 3, it's positive, so we know that x is less than 10 feet because the x is feet and the 3 is feet, and that's where the 30 square feet comes from. So as long as that height of that trapezoid is less than 10 feet, the area will be less than 30 square feet. So this is not your homework, this is classwork for tomorrow, but if you happen to be absent tomorrow, then go ahead and do these problems, and you can check them when you come back to school. Don't forget the calculator worksheet, just those 4 graphs that you're going to just reproduce on the calculator. And don't be afraid to play around with, push some of the buttons, look at the menus, see if you can discover some things about your calculator in the graphing mode. All right?